In this video, I'm going to talk about the inverse trigonometric functions and how they work with our regular trigonometric functions in order to combine together, and then we can solve problems involving those. So first, let's just talk about functions in general. When we talk about, in algebra, f of x, maybe we say f of x equals x squared. So our input in that case is a number, and the output is also a number. And they may have a meaning in the context of a particular problem, but generally speaking, we're just looking at a number going in and then a number coming out. When we're working with trigonometry, it's a little bit different. So now suppose we're talking about f of theta equals the cosine of theta. So here we have a function. My input is theta, and this is an angle. And the output that we get when we take the cosine of theta is a ratio. And in the case of cosine, that ratio would be x over r. And of course, if we change the trigonometric function to tangent or cosecant or something like that, then the ratio changes. But in any case, we have the angle as the input and the ratio as the output. And that's what we're going to want to be conscious of in these problems. So when we're working with our trigonometric functions, now I'll switch to sine. So I have here the sine of an angle equals a ratio. And now if we were to reverse this, if we're talking about an inverse function, then I can express this as the sine inverse of a ratio equaling an angle. And of course, another way to express that would be to say the arcsine of a ratio is equal to an angle. Okay, so when we are looking at our regular trigonometric function without the inverse, we take the trigonometric function of an angle, we get a ratio. Inverse trigonometric function, whether it's sine inverse, arcsine, whichever format, we're taking it of a ratio and we get an angle. So what this enables us to do is to solve certain problems like the following. Here I have the sine of the sine inverse of a ratio, y over r. And so when I take the sine of the sine inverse of y over r, I know that sine inverse of y over r, so I'm taking sine inverse of a ratio, and I'm getting an angle. And then I want to know, well, what is the sine of that angle? And of course, that's going to turn out to be y over r. So we have the sine of sine inverse of a ratio is going to turn out to be a ratio. And suppose I have sine inverse of sine of theta, then this can turn out to be theta. Now, we have to be careful with these because we have a very particular domain and range that we're talking about when we're working with the inverse trigonometric functions. So let's take a look at how to deal with those cases. Let's take a look at example 1 here. It asks us to find the cosine of the cosine inverse of 1/7. So before I actually solve this problem, I can't just assume that the answer is going to turn out to be 1/7. What I have to check for is that this value is in the domain of the cosine inverse function, or the same thing would be to make sure that this value is in the range of the cosine function. So either way that works. And we know that the domain of the cosine inverse function is -1 to 1. So since 1/7 is within the range of -1 to 1, then we can go ahead and evaluate this and say that our answer is 1/7. Now in example 2, it asks me to find the cosine of the cosine inverse of 7. And of course 7 is not within the boundaries of -1 to 1. So I would say for this one, not defined. So there's no way to solve this problem because we can't take the cosine of an angle and get 7. That's not within our range of the cosine function. We have a similar concern when we reverse the order of our trigonometric functions, the inverse and the regular trigonometric function. So if the inverse function comes first, here, and then we're taking the inverse cosine, for example here, of the cosine of an angle, then we know that our answer should be an angle. So what I'm looking for is this angle within the range of the cosine inverse function, or likewise, is it in the domain of our restricted cosine function? So our restricted cosine function has a domain from 0 to pi, and pi over 6 is within that range of values from 0 to pi. So the cosine inverse of cosine of pi over 6, I'm just going to say is pi over 6. Very straightforward, very nice. A little bit trickier when we take a look at example 4, and we have cosine inverse of the cosine of 5 pi over 4. And of course 5 pi over 4 is not within the domain of our restricted cosine function. Now we can still evaluate this, but it's not going to come out to 5 pi over 4. So what I'm going to do is I'm going to draw my x and y axes, and I'm going to locate the angle 5 pi over 4, and that's actually in quadrant 3. So I've got 5 pi over 4 lands in quadrant 3. And what do I know about quadrant 3 and the cosine function? I know that the cosine is negative within quadrant 3. So here we have a negative cosine value, and since I can actually talk about 5 pi over 4, I know that the point here is negative square root of 2 over 2, and the y value is also, a little space here, negative square root of 2 over 2. So, how do I find the cosine inverse of this angle? What I'm going to do is I'm going to look at within the values that we're allowed to use. So we're only allowed to use 0 to pi. And where would we get a negative result or negative ratio for cosine within that range of values? And that would happen in the second quadrant. So I'm going to switch to the second quadrant, right? But the same type of angle. So it's a 45-degree angle or a pi over 4 angle. So this would be 3 pi over 4. And there's my answer. So I just find the corresponding angle that matches up that either gives me a negative or a positive depending on what this one was doing. So this one was giving me a negative, so we got 3 pi over 4. Now let's take a look at cosine inverse of the cosine of 7 pi over 4. So this is a somewhat similar problem. Here we have 7 pi over 4 in quadrant 4. And here I know that the cosine comes out to be a positive. It's square root of 2 over 2. And the sine is negative square root of 2 over 2. But we're just concerned with cosine here. So where is the cosine going to have a positive value within 0 to pi, and I need the ratio to come out to be the square root of 2 over 2. Well, that's going to be in the first quadrant, and this is just pi over 4. Another way of looking at this is 7 pi over 4 is coterminal with, see if I can write this real quick, negative pi over 4, right? So we know that. And if I'm taking the cosine inverse of the cosine of negative pi over 4, well, cosine of negative pi over 4 is just the cosine of pi over 4. We know that because of our even and odd properties. So now I've got cosine inverse of cosine of pi over 4, and that also leads me to pi over 4. So a couple of different ways to solve that same problem. In the next video, I'll talk about how we combine different trigonometric functions together.